Everyone, happy new year. Welcome back to this channel. In this channel, if you're new here, we revise for exams. We help students go through all the questions that they would deem necessary for us to help them revise, especially in building and civil engineering courses. And right now we are concentrating much on estimation and costing of building works. So we have been doing takeoffs for different parts of the building, and right now I am doing a video that someone asked for. When we are taking off, what if there are curves or circles? What do we do? So we are doing a question that have a semicircle, and this one will guide us when we are revising, just in case we find a question that have curves or any other shape. It's the same concept. So welcome back. If you're new here, kindly subscribe, join our community. In this channel, if you have any question, you just put it in the comment section. I'll be able to see it and I will do a video for you, or I will help you get to understand more. So if you have any questions, you shall just write them there and we shall go on together. So in case you have any other area that you would like us to discuss, you just write it there and I will be able to look into it and I will respond. So thanks for subscribing. We shall be continuing to do more takeoff videos. For example, there are those who have asked for more complex roof takeoffs, and there are some other takeoffs for the manholes. We have takeoffs for the substructure works with columns, and superstructure works with columns, and basement with columns, and those ones are the videos that I'll be posting after this. So we hope to be a bit more consistent now that it's a new year. We expect a video after every one day, and kindly keep watching and kindly give us your feedback. It encourages us and it keeps us knowing that you are there watching our videos and we should make more for you. So let us get into this video whereby we shall be answering this question, and enjoy. And in this question, the question was, take off all quantities for the substructure works shown on the drawing number 1 up to and including damp-proof course. So in taking off, we are given the plan. We can see the length, we can see the thickness of the wall is 200. Then we can see we have 5500. We have 200 as the width of the wall, the thickness of the wall. Then we have 6000. Then we have 200. Whenever I am pointing out anything on the diagrams, I use the red pen, so you can follow through using the red pen. On the length, we are also shown here up that the 6000 is the diameter of the curve. Okay, let's go to the width. The thickness of the wall is 200. Then you can see 5000 between the walls, 200 for the walls, 4500 between the walls, and 200 the thickness of the wall. We can see section YY. Section YY is here on the wind side. So here we have section YY. So when we are looking at the section, we shall be looking the section from this part. So let's go to the section. On the next slide, we shall see the section, and it's here. Let's study the section. We are told we have the DPC. The DPC is here. It's usually below the wall. Then we have 19 millimeters thick rendering here. Then we have 100 millimeters concrete, ratio 1:2:4. Then we have 25 millimeters blinding to 50 millimeters hard coal. We can see it here. This wall is 200 millimeters thick natural stone. Then we have the plain concrete down here. The thickness of this foundation, strip foundation, is 600 millimeters. Then the thickness of this concrete in the foundation is 200. We have the height of the wall below the ground level is 900. Then above the ground level to where we have the concrete, the top of the concrete is 200. Then we are told that the site is bushy. Then vegetable soil average 150 millimeters deep. That one is the vegetable soil we shall excavate. Then we are told to ignore formwork. So we shall now get taking off substructure works. We said we have a procedure. We start with site clearance. We shall clear the site of all bushes, shrubs. Because we have been told the site is bushy, we shall clear it of all bushes, shrubs, any stones, and take them away from the site, clear the site. Then we shall excavate the oversight. The oversight is the vegetable soil, which you have been told is 150 millimeters deep. Then we shall excavate the foundation trenches. Then we shall lay the concrete foundation in the trenches. Then we shall do the foundation walling. We do the hard coal inside the walls. We do the maram grinding, which is done on top of the hard coal. Then we do the DPM and anti-termite treatment. We do the floor bed. Then we render with painting, because we were supposed to do the formwork after the floor bed in takeoff, but now we are told to ignore formwork, so we shall render with painting. So we shall begin with site clearance. In site clearance, we shall divide this plan into two. There is this semicircle here. Then we have this rectangle. This rectangle starts from here. Kindly follow through using the red pen. It goes like this way. That's another rectangle. So we shall take off site clearance for this semicircle here separately from this rectangle. Then when we are taking off for this rectangle, we shall take the area of the whole rectangle. We deduct the whole rectangle. We deduct this part which is not involved in this building. So let's start with the big rectangle. For the big rectangle, we shall take the length. The length, this one is 5500 plus 6000, that is 11500. 11500 is here. Then we go to adding the walls. The walls, how many walls do we have? We have these 1, 2, 3 walls. So we get, you remember we are finding the total length. So we have 3 walls and each is 200. So the total thickness of the wall is 600. Then we shall add projection. How do we find projection? Projection, if you look at this black part, we are finding, you use the foundation spread, which is in the section. The foundation spread is 600. We less the walls. The walls is 200. So 600 minus 200 is 400. 400 divided by 2, we shall get the projection of the walls on both sides. The projection of the foundation base on both sides. And the one we are concerned with is on the external part, because that one we have to cater for it where the projection will be. We shall have to add that length when doing site clearance. So the projection on each side, for example on the length side, this side we shall add 100, then the other side we shall add 100. So on each length we shall take two sides, and we shall add 200 on each side, because the projection is 200, not 100, 200, because a half of 400 is 200. So the projection on the total length will be 2 times 200, 400. So what is the total length of that rectangular part that you are going to do site clearance? It shall be 11,500 plus 600 plus 400. We get 12,500. We go to the width. The width, we shall take 5,000 plus 4,500 in between the walls. We get 9,500. We add the walls. How many walls do we have? 1, 2, 3. This one, 1, 2, 3. So 3 times 200 is 600. So we add projection this side and this side. So it shall be 2 times 200, 400. So the total length of the bigger rectangle shall be 9500 plus 600 plus 400. We get 10500. Then we shall come and deduct. Once we are done, we shall deduct this part. This part is part of the big rectangle, but we are not using it. So we shall deduct that area. So let's first jump to here, deduct detail. Here to deduct detail, we shall take the length of that rectangle, which we are not using it, 6000. It's 6000 plus this 200 for the wall. It shall be 6.2. Then the width, it shall be 4500 from here to here plus the walls 200, 4700. So when you are filling it in, it shall be 4.70. So when we deduct 6.20 and 4.70, it shall have not included the projection, because the bigger rectangle already has the projection. So we shall just take 6.20 and 4.70. I hope that is clear. Yes, we shall take 6.20 and 4.70. We shall not add the projection because we are finding the area that we shall not be using. So that we take the total area of the big rectangle minus the area of the unused parts to get the total area of the site, the area of the site that shall be cleared and shall be used. So let's go back to the semicircle. What is the area of that part that we shall be using? So on the semicircle part here, the area of a semicircle is equals to pi r squared. What about a half semicircle? A half a circle, that is a semicircle, it's a half pi r squared. So a half pi, we shall put it on the times in column here, a half pi, then r squared, we shall put it here. So what is the radius? If the diameter is 6000 and we haven't added projection on both sides, because we shall add, if it's up to here 6000, then we shall be having a projection. For example, take it as here, from here, if the diameter is 6000, it's from here to here. Then we shall add 200 here. So what will be the radius of that semicircle? It shall be, if it was 6000, we add 200. 6200 divided by 2, 31. So it shall be a half pi, 3.10, 3.10. So that will be the area of that semicircular parts. So I hope that is clear. So let's continue. So for the site clearance, it shall be clear site of all bushes, grass, undergrowths, and burn all arising, and excavate away 150 millimeters deep to remove vegetable soil and deposit it. Some SH, we say this, deposit in soil heaps on site, average 150 millimeters distance from the site, and deduct detail. That one shall have given us the total area that we shall use for the building, and that is the total area that we shall do site clearance. Excavation of the foundation trenches. That one we usually use the center line. The center of the foundation trenches is the center line of the walls. When we talk about center line, we shall be moving around the building, walking at the center of the wall. So if we start, for example, here, we shall start here. Let's start from here. Here, from here at the center of this wall to here, it's 100. Then we add 4500. We add 200 thickness of the wall. Then we add 5000. Then we add 100. Then we add 100. Then we add this length 5500. We are working at the center, 5500 up to here. Then we add 100 to get to the center here. You see? Then we want now to move from here at the center. We move around this semicircle. I'm using a mouse so that it might not be so perfect. We move in between through at the center up to here. That one, that curve we shall find if the circumference of the circle is usually 2 pi d. So for the semicircle it shall be a half pi d. What is the diameter of this semicircular part? If the total diameter was 6000, then we subtract this 100. No, if the diameter of the total semicircle was 6000, then we subtract 100 for the wall. It shall be 6000 minus 100. 100 is half the wall, so it shall be 5900. So to find the circumference of that semicircle, it shall be a half pi d, and the d is 5900. So it shall be 0.5 times 22/7 times 5900. 0.5 times 22/7 times 5900. 0.5 times 22 times 5900. Then we divide by 7. We shall get 9271. 9271.43. So that is the circumference of that semicircle. Then we add from here down here, it's 200. Then up to here 5000. Then 100, then 6000, then 100, 4500, 100, 5500 plus 100. Then we go to here, 100 up to there plus 5500 plus 100. So once we get the total length of all these, we shall get the length of the center line. So we are excavating the depth of the foundation trenches. What will be the depth of the trench? So we shall excavate from the ground level here. We can see that from the ground level the height of the wall is 900. This 900 is here. Then we add 200 for the vibrated reinforced concrete. 900 plus 200 shall be 1100. 1100, then we shall less 150 for the excavation of oversight. It shall be minus 150. So 1100 minus 150 is 950. So at the trenches we shall excavate is the depth is 950. We have less 150 because we had already excavated it for the oversight. So the volume of the soil that we shall excavate for the foundation trenches, we shall take the center line of the walls, we multiply by the thickness of the trench, we multiply by the depth of the excavation. The depth of the excavation from ground level to the bottom of the trench. So center line going all around, then we multiply by the thickness of the trench, 600 millimeters. Then we multiply by the depth of the trench. Center line times thickness of the trench times the depth, 0.95. So excavate foundation trenches commencing at stripped level not exceeding 1.5 meters deep. We said it's not exceeding 1.5 meters deep because in the SMM we excavate in ranges of 1.5 meters and refill and ram. Planking and strutting to sides of excavation trenches and keeping the trenches free from all waters. We said that one we shall write item because this one is a provisional. Some shall be provided in the BQ because the extent of the work can only be known once we visit the site, but on the drawings we cannot be able to estimate what is the level of planking and strutting necessary and also the extent of the waters that need to be dewatered. So we go to mass concrete in foundation strip, and this one is usually calculated in terms of volume. So to get the mass concrete in the foundation strip, we shall take the center line of the walls, then we take the thickness of the trenches, which is 600, then we take the depth of the plain concrete, which is 200 millimeters. So mass concrete ratio 1 is to 3 is to 6 in foundation strip, and deduct RFR. RFR is the soil heap that had been put aside to refill and ram. And also cut away is that heap of soil that had been used to what had been put to dispose. So because we have replaced the soil in the trench with the mass concrete, that volume of the concrete shall be deducted from the volume of the soil that had been put aside to refill and ram, and it shall be added to that heap of soil that shall be used to dispose from the site, which is called cut away. Now go to the measuring the area of the walls for the foundation walls. Yes, area of the foundation walls. The area of the foundation walls is usually equal to the center line times the depth of the wall. So what is the center line? The center line, we have already found it. Then the depth of the wall. The depth of the wall, it shall be equal to from the ground level, it's 900 plus 200 below for the 200 above the ground for the wall and the concrete. So it gives us 1100. Then we shall deduct 100 millimeters concrete to get the length of the depth of the wall. So 900 below the ground plus 200 above the ground, 1100. Then we subtract 100 millimeters for the concrete. We remain with 1000. So the depth of the wall is 1000. So we shall take center line times 1000 depth. 200 millimeters thick stone walling in cement sand, ratio 1 is to 3 mortar joints. Now we want to find the volume of the soil that we shall deduct from RFR and add to cut away because it has been replaced by the volume of the wall. So that one we shall take the volume of the wall. How do you find the volume of the wall? The length is the center line. The width is 200 millimeters thick. Then the depth is, we shall take the depth of the wall minus the oversight. You know we had already excavated 150 millimeters, so that one we shall deduct. So the depth shall be the depth of the wall, the height of the wall below the ground, because the wall below the ground is the only wall that is replacing the soil. So below the ground the wall is 900. We less the oversight we had excavated is 150. So the depth of the wall that has replaced the soil below the ground is 750. So the volume of the soil that has been replaced by the volume of the wall is center line of the wall times the thickness of the wall times the depth of the wall below the ground minus the oversight. So it shall be, we start with center line as the length, then we go to the width, which is 200 millimeters, then the depth of the wall. So we shall say deduct RFR and add cut away. We center line of reinstatement, it shall be that area outside the walls whereby we had excavated the vegetable soil and it's on the projection parts. Remember, projection is that part that has the foundation concrete below. So that projection, which was 200, will go all round. Where we excavated the vegetable soil, we need to replace it because we shall not be using that area because it's outside the walls, because on the inside we shall put the hard coal and everything, but that area we needed to reinstate it to the previous height. So there we usually calculate the volume of the soil all around. So the center line of the reinstatement, we shall take the length of the external walls, then at each corner we shall add 100 on each corner. For example, we shall do like this. We start from this corner that we do start from here. We shall take the projection was 200. This side was like up to here 200 and up to here 200. So it shall be like this. So the center line of reinstatement, we shall start from here. From here up to here, it's 100. Then we take this total length. Then we go up to the end of the external wall. We shall add 100. Then to here 100. Then the total length. Then up to here. Then from here we shall less 100. From here up to here we shall less 100 on this length. So from here we shall take the circumference of this semicircle. From here we go round. What will be the radius of that semicircle? The diameter, it shall be this. There's the previous one from here up to here was 6,000. So we shall add 200. So we shall take a half by d. A half 22 over 7 times 60, 200. It shall get us to here. Then we add this length coming down here. Then we shall add 100. We take this length, but we shall deduct 100 from here to here, so that we can get the center line of the statement. Then we add this length up to here. Then we add 100. Then we add this length. Then here we shall add 100 here. So if you follow through, you'll be able to see even using my dimensions. If we add those total lengths, we shall be able to get the center line of the reinstatements. So for the volume of the soil that we shall use for reinstatement, it shall be the center line of the reinstatement with times the width of the projection outside the house times the depth of the vegetable soil, which was 150. So we shall start with center line of reinstatement, then the projection, then the depth of the vegetable soil. So we shall say remove from spoil heaps, and add a refer, or remove from cutaway and add a refer. We go to hard coal. This when you are doing hard coal, we do it inside the walls. So we shall start with we shall divide this into 3 areas. So let's start with this smaller rectangle. The width is 4500, the length is 5500. So the area of this rectangle here, it shall be 4500 and 5500. Then we go to the bigger rectangle with the width is 5000, the length is 5500 plus 200 plus 6000. The width is 5500, the length is 5500 plus 200 plus 6000. So that one will give us 11.70. This one, and the width is 5000. This one we had said the length is 5.5, the width is 4.5. So we shall go to the area of the semicircle, this semicircle here, which we shall do hard coal. So the area of the semicircle, if the radius, the diameter from here to here was 6000, that's the same from here to here, it was 6000. So if we deduct this wall, which is 200 millimeters thick, it shall be the radius was 6,000 divided by 2, 3,000. 3,000 minus 200 is 2,800. So we shall take a half pi r squared. R is 2.8, 2.8. So 100 millimeters approved hard coal were ramped and compacted, and on the same area we shall do 50 millimeters thick approved maram blinding, and on the same area we shall do street surface of hard coal with approved insecticide. That's total area. We shall do the three things. We shall go to DPM. DPM with 150 millimeters laps. DPM is usually done even on top of the walls. So we shall find the area of the three parts including the walls. So we start with a small rectangle. At the small rectangle we shall take 200 plus 555 plus 200. We get 5,900. Then we go to the width, 4,500 plus 200, 4.7. We go to the bigger rectangle. The bigger rectangle, the length, it shall be 200 plus 5,500 plus 200 plus 6,000 plus 200. We get 5.4. No, 12.10. And the width shall be 200 plus 5,500 plus 200. We get 5.4. So the area of the semicircle now, from here, the area of the semicircle, we shall take a half pi r squared. The r from here outside the wall to here is 3 meters. So a half pi 3, 3. 1,000 gauge DPM with 150 millimeters laps measured net and 150 millimeters mass concrete 1:3:6 floor bed laid on hard coal and finished to receive floor screed. 19 millimeters thick render and painting. It's shown on the section parts, this part here. So this one we shall calculate it like skirting in terms of linear meters, and it's going outside the walls all around. So we shall find the perimeter all around the external walls. So we shall start from here. So here we shall start 200 plus 4,500 plus 200 plus 5,000 plus 200 plus 5,500 plus the perimeter of this semicircle here, a half pi d, and d is 6,000, then plus 200 plus 5,000 plus 200 plus 200 plus 6,000 plus 4,500 plus 200 plus 5,500 plus 200. That one, it shall give us the total perimeter outside the walls. So it shall be 53,101.43. So it shall be 53.10, 19 millimeters thick render and painting. So we are done with the substructure works. If you have liked this video, kindly give it a thumbs up or like this video, and if you haven't subscribed, kindly subscribe, and we shall continue making good videos for you. So thanks for watching and see you in the next video.